Networking layer. It's important to have a good routing. Good routing means that the packets follow the path that is right for the situation. How do we define a good path? First of all, the path is a series of routers which packets will traverse from a source host to a destination host. The terms for a good path are a low-cost path, the fastest path, and the least congested path. A good path includes all of these terms. Ideally, we would like to have the lowest cost, so we will define the meaning of cost to have the fastest path and the path that is least likely to have congestion, to create traffic, to have packets crash. So first of all, we'd like to take a look at a certain practical example. Here we have an example of several routers that are arranged with several links in between. The numbers that appear on the links are the cost of transferring packets. It's easy to understand cost as a financial term. Cost can definitely mean how much it would cost me to transfer 1 megabyte via a certain path. And it's indeed one of the cost's formations. It can also be how effective this path is. How fast can packets traverse the path? Because our objective is not just having the lowest cost traffic. Sometimes our objective is to give the best user experience, meaning that the user's packets will arrive as quickly as possible. The faster they arrive, the less it takes to transfer packets. Cost is still a term that depends on our settings. In different cases, it can be related to bandwidth. Where we'd have bandwidth, the cost would be lower. To congestion or network conditions. The more congestion we have, the cost would be higher. It can also be in the relations between internet providers. Monetary cost can certainly be assigned to paths. If we look at a graph created from a set of routers, U, V, W, X, Y, Z, and there is a cost between them, and every link as a routing decision, we are only interested in finding a working path. That's the first thing. Second, to find the path with the lowest cost. So we have a series of links, and we have a set of routers. Once we look at the path and search for the lowest cost, we will find it, and it will always be if the cost of every link is known. Then we would have the least cost path between U and Z. The routing algorithm should do the following. A. Choosing a path. B. Choosing the lowest cost path. Let's look at routing algorithm classifications. Basically, there are two main classifications. One is global routing algorithm. When all routers see the topology and know all the costs of every link in the router's set. Every router sees the situation clearly. This is why it's called global. It's also called link state routing algorithm, because we know here the state and cost of each link. It has advantages and obviously disadvantages. There is also a decentralized algorithm. Routers that know only about their neighbors and know only the traffic cost to the neighbors. They require an iterative computing process, and actually the routing algorithm can move from router to router in order to make the computation. Another name for a decentralized algorithm is a distance vector algorithm. Of course, there's the issue of how quickly the link's cost is changing. A particular case of change in the link's cost is links crash. Static algorithms, usually, assume that the cost changes very little or almost never changes. Dynamic algorithms assume that they don't make this assumption and are capable of having periodic updates and reacting to cost changes or links crash.